Hello, geometry students. We are about to begin our next unit on congruent triangles, and our first lesson is about marking the picture. We are going to review 6 terms and how they create congruent sides and angles in a picture. This is extremely important for proving triangles congruent, because when we get into proving triangles congruent, we're looking for which sides are equal to each other and which angles are equal to each other. And we are going to talk about 6 terms, just what do they mean in general for geometry, and then how do they apply specifically to our unit on congruent triangles. The first term is bisect. Bisect means to cut in half. We can bisect angles, and we can bisect segments. A segment can be cut into 2 equal or congruent parts, and an angle can be cut into 2 equal or congruent parts. Now, an example right here, let's say that we have a segment AB that bisects segment CD. That means we have a segment CD and another segment AB. And if it bisects segment CD, that means that CD is a segment that is being cut in half. If it bisects CD, then we will have segment CB is congruent to segment BD. That's what it means to bisect a segment. To bisect an angle, let's try here. Ray AB bisects angle CAD. So if we had something that looked like this, where we had angle CAD, and then if we had ray AB bisecting it, bisect would mean cut in half, so that this part, CAB, would be congruent to angle over here, BAD. Now sometimes we have segments that bisect each other. If we have AB and CD bisect each other, then that means that would be kind of like our original picture up here. If CD and AD bisect each other, then that means each one of them is cut into congruent parts. So here, and also these two would be congruent to each other. Our second important word is midpoint. Midpoint we talked about before, and it's exactly what it sounds like. It's the point in the exact middle of a segment. A midpoint divides a segment into 2 equal or congruent parts. Let's say we had a segment right here. Let's call it MN. And if P, let's say if P is the midpoint, I should say P is the midpoint of MN, then that means that segment MP is congruent to segment PN, because middle means points in the middle, and those 2 segments are equal to each other. They are equal halves. Our third term is perpendicular. Perpendicular means when 2 lines intersect to form right angles. Right angles. Segments that are perpendicular, they form 4 right angles at their point of intersection. So if we had, for example, segment AB is perpendicular to segment CD, then we would have a couple of segments right here, and they would form a right angle. Now if we've got a right angle here, we've got a right angle here, and if this segment keeps going, then we would have right angles all the way around. In triangles specifically, if we have something that is perpendicular, let's imagine that this is perpendicular right here, then we would have a right angle over here, creating a right triangle on the right, and a right angle over here, which would create another right triangle on the left, so we would have 2 right triangles there. All right, our fourth term is parallel. Parallel lines are lines that never intersect. And parallel lines tend to, we had them looking like this before. Parallel lines will either be given information that say they're parallel, or they will be marked with the little arrows or sometimes triangles that indicate they're parallel. And when two parallel lines are cut by a transversal, the alternate interior angles are congruent. We learned in our unit about parallel lines, we learned about all kinds of angles. We talked about corresponding angles, alternate interior angles, alternate exterior angles, consecutive interior angles, and consecutive exterior angles. But the ones that are going to be relevant to us in our triangle unit are the alternate interior angles. So in this example, this angle up here and this angle down here, these are alternate interior angles. They're congruent to each other. And also this and this. The ones that I've labeled in purple are congruent to each other. The ones I've labeled in green are congruent to each other. When we're talking about triangles, we would most likely see something that looked kind of like this. And if we were told that our lines are parallel, I'm going to put a little symbol on there for parallel, then we would know that certain of these angles are congruent. Even though this figure doesn't look exactly like the one at the top with two parallel lines cut by a transversal, they don't keep going. Here in this case, we would still have this angle up here and this angle down here that are alternate interior angles with each other. And we would also have this angle up here and this angle down here are alternate interior angles with each other. Our next term we're going to talk about is vertical angles. Vertical angles are angles that are across from each other formed by two intersecting lines. And vertical angles are always congruent. And I've said before, and I'll keep saying it, even if you come away from geometry only remembering one thing, let it be that vertical angles are congruent to each other. So in a regular example, that would look something like this, where we have these two intersecting lines, and we would have the vertical angles, this angle and this angle, are vertical angles and therefore congruent to each other. And another pair of vertical angles in this picture would be here and here. These are vertical angles. They are congruent to each other. Now, how is that going to apply to triangles? We might have something that looks like, again, similar to what we had last time, something like this, where we have two triangles that are touching. And in this case, then we would have vertical angles right here and right here that are congruent to each other. And our last term that we're going to talk about in this video is a shared side. And that is a side that is common to two triangles. What we might have in a problem might be here, one triangle, and here another triangle that's connected to it. And you see how they share this side right here? Well, the side is the same length in both triangles, and we would just mark that with one line. You might also see an example that looks like this, where we would have we have multiple triangles here, and they share the same side. So the side that is part of both of them, it's the same length in both sides. In both triangles. That might sound kind of silly because everything's always equal to itself, but it is actually pretty important for us when we're proving triangles congruent. Now, usually they won't tell you it's a shared side. You just need to be able to recognize it from the picture. Okay, so after this, there is a practice paper on marking the picture. Please do that, and if you have any questions, bring them to our next class.